All right, first thing I would like in front of you is the Graphing Systems of Equations note packet, please. Make sure you have a pencil and a calculator out. What we are learning today is new. So this is something we have not done yet this year. Some of the stuff we are talking about is going to sound familiar, but we're doing it a little bit differently. So this is called Graphing Systems of Equations. So it all goes back to this. Do you guys remember learning about solving equations and then deciding if it had no solution, one solution, or infinite solutions? You remember that, okay? So it all goes back to this. So if you know how to solve these, you're going to be just fine today. The only thing different about it is that we are graphing them, okay? So in other words, you're going to be graphing two lines, and then you're going to be deciding what happens when both of those lines are graphed. So here are your steps. You're going to put the equations in slope-intercept form. In other words, y equals mx plus b. You're then going to graph the equations. We're not going to be necessarily graphing today. We're just going to be getting y by itself, looking at what we have. Eventually, we will be graphing. And then eventually, we're going to name the point of intersection if there is one. So what are the three types? So if you see on the board over here, this is kind of what we're going to be eventually getting to. We're going to be seeing different situations when these lines are graphed. So if you have one solution, this is the part that's important for today. So if you have one solution, that means there's an intersection point. Think of that point as the solution. If they cross, that point is the solution. Meaning your slopes are different. You're going to have a positive and a negative slope in order to have lines that cross. And then they are intersecting at one point. I tend to say that their intercepts are different as well. So that's one solution. No solution, think about they're not touching at any point. So there is no solution. It's going to create parallel lines. Do you see how parallel lines have the same slope? It's literally the same line, one's just below it. Yep. So the slopes are going to be the same, your y-intercepts are going to be different, and there's no intersection point, which means no solution. The last one is infinite solutions. Both lines create the same line. In other words, they are the same. They're on top of each other, which means the slopes are the same, the y-intercepts are the same. They are intersecting infinitely. In other words, they are touching in infinite points. Okay? So that's the three of them. And then here are some of them that we will eventually graph. We're not going to do graphing today, though. We're just going to be looking at the basics. Okay, so keep this packet, because eventually, I think 2 days from now, or tomorrow, well, yeah, Wednesday for you guys, we're going to be graphing them. So what you really need to focus on today is what your slopes are doing and what your y-intercepts are doing. Okay? So look over here at the board. I'm going to move my camera here, but look over here at the board. I have 3 pictures drawn for you. Okay. So the red graph is talking about no solution. Notice the slopes are the same, but you have different intercepts. The blue graph, this is one solution. You have different slopes and different intercepts, which means they're going to intersect at a point. And then you have infinite solutions, which is the same line, which means same slopes and intercepts. You're going to need to know this today as we work through these. So now we are going to start our worksheet.
The one that Charlie handed out to us.
Say what?
The one that Charlie handed out to us.
Keep your notes out. Don't put those away. But yes, the one that Charlie handed out to you. If you are good at getting y by itself, then today's lesson will be pretty easy for you. Because that's really all we're going to be doing. We're going to be getting y by itself, we're gonna be looking at the equations that are then given, and then we're gonna decide what we notice. Are the slopes the same? Are the intercepts the same? We're gonna be drawing conclusions based off what we get. So first thing we have here, we have two equations. What are we gonna need to do first? How do we simplify?
Get y by itself.
We are gonna get y by itself. So for this first one, I'm gonna divide both sides by 6. So I get y equaling 2x plus 6. And for your next one, we're gonna have to divide both sides by 15. So I'm gonna get y equaling 3x plus 4. So right now, let's look at what we have. What do you notice about the slopes?
They're different.
They're different. What do you notice about the y-intercepts?
They're different.
They're different. So what are we gonna have here? We are gonna have one solution. So this is how you fill in your boxes. The slope of the first equation is not equal to the slope of the second equation. The y-intercept of the first equation is not equal to the y-intercept of the second equation, which means there is one solution. So really, you're just looking at the slope and the y-intercept and then making a conclusion. So let's try number 2. The first one, y is already by itself, so that one's ready to go. This next one, we need to get y by itself. Xander, how do I do that?
Should be before dividing 4.
Divide both sides by 4. Alright, Zach, what do I get when I divide both sides by 4?
Y equals 3x plus 16.
Nice job. So what you are paying attention to now, you have y equals 3x plus 14 and y equals 3x plus 16. What did you notice? Slopes are the same. So when your slopes are the same, what are you gonna have? No solution. In other words, you have the same slope, which means they will not cross. So this is no solution. So I'm gonna say slopes are the same, which means no solution. Alright, moving on to number 3. I'm just kind of going around the room here. Macy, the first equation, what do I need to do to get y by itself? What would be a first step?
Subtract it into the x.
So subtract x to the other side?
Yeah.
Okay. So 3y is going to equal negative x. Lily, what do I do next? Divide both sides by 3. So this is y equals negative 1/3 x. How do you know when you're done? Like, how do I know I'm done with this equation? There's nothing else to do. Y is by itself, your x is on the other side, you have nothing else. Okay, so Braylon, we're now working with this equation. Let's get y by itself.
Divide 9.
Good. So when I do that, I get y equaling negative 3 over 9 is the same thing as negative 1/3 x. So I have negative 1/3 x, negative 1/3 x. Alright, so this is going to be infinite solutions because you have the same line. Okay, this is like your mirror image. Same thing on both sides. So we're going to say same lines, which means infinite solutions. Are you getting the hang of it? Okay. All right, number 4. Ben says the system of equations has one solution. Is he correct? Alright, Bryson, this is your question. If you need to, tell me what you notice about the equations.
They both have the same number.
They both have the same
X.
slope. They have the same slope. So what does it mean if they have the same slope? Look up here if you need to.
I mean, that's,
Well, if they have the same slope, they would also need the same intercept, which they don't have.
the solution.
Yes, Levi, very good. No solution. So we will say no. When lines have the same slope, and different y-intercept, they become parallel. Parallel lines have no solution. I know that's a lot to write, but it's important, okay? Alright, number 5. It asks us how many solutions does this system have? It's a system because it's two things working together, okay? So if you notice, both of them need some work done. We need to get y by itself. So, Levi, which one would you like to start with? Top or bottom?
Top.
Okay, what's gonna be my first step to get y by itself?
You subtract x.
It's currently already a -6, so to bring it to the other side,
Add it. to the other
okay,
side.
so I have 18y equaling positive 6x plus 264. Okay, Wyatt, what do I do now?
Divide the 18 on your side.
Good. Okay, when I divide it, I'm gonna get y equals 6 over 18 is 1/3. And then 264 over 18. Did you guys get like a really ugly number? Okay, I'm just gonna leave it as 14 2/3. Okay, so I left it as a mixed number. Alright, Dean, I'm working on the second one now. What am I gonna do first to get y by itself?
Switch the x and the y around. Move 36 y to where 12x, -12x is.
No, you don't want them on the same side. So like all class so far today, we've been taking the x and moving it to the other side.
Yeah.
So move this to the other side. When you move it to the other side, what happens?
It becomes positive.
Okay, so I have -36y equaling positive 12x plus 130. Math builds, guys. We've been doing this since your sub was here, okay? Now what do I do? Madison?
Divide them all by -36.
Very good. Alright, so y is gonna equal I get -1/3 again. And then 130 divided by 36. -3 and 11/18, okay. Well, we gotta look at these very carefully, guys. We have 1/3 x plus 14 2/3. and then negative 1/3 x minus 3 and 11/18. Is anything the same? The slopes are different, y-intercepts are different, so what's your answer?
One solution.
One solution, yes. Okay. Looking at number 6, we notice that the y's are already by itself. The y-intercepts are the same, but your slopes are different. So what are you gonna have here? One solution, yes. That's why I said like the middle one there, one solution, it doesn't always have to have different intercepts. Sometimes they can be the same. So this is going to be one solution because your slopes are different. Alright, we're almost done. Alright, number 7. The system of equations below shows the distance in miles, y, two trains travel in time, x. What conclusion can you make about the system of equations? Interpret your result in the context of the problem. Okay, so Sam, what I want you to do, notice train A is good to go. How do I know it's good to go, guys? Y is already by itself. So train B, Sam, what do I need to do?
Divide 7 into 11.2.
Alright, so we're gonna divide both sides by 7.
Thank you.
I got the same thing. You guys get the same thing?
Mm-hmm.
Okay, so if they are the exact same, what type of system do we have here? Infinite solution. So what does this mean about the trains? What does slope tell you?
Probably at the same.
Okay, so it's like the rate of changes are the same. So in other words, the trains are traveling at the same speed. What does your y-intercept tell you? Anytime you are graphing, I always say, what do you do with the y-intercept? What does the y-intercept tell you?
What speed?
Where you start. So in other words, the trains start at the same point. In other words, the trains are going to be doing the same thing all the way through. Same starting point. Come on, focus. There we go. Okay. All right, number 8. Does the system have one solution, no solutions, or infinite solutions? And then we're going to write another system that's going to have the same number of solutions using the first equation. All right, Mackenzie, working with that first equation, what will I do first?
Subtract 15x to the other side.
Okay. All right, Evelyn, what am I going to do next?
Divide.
Divide both sides by 65. So this gives me y equals, get something really ugly, negative 3 over 13x plus 37 over 13. All right, Charlie, what am I gonna do with my second equation here? First step.
You're gonna move the 12x and have it negative 52y plus 12x.
So you're adding it to the other side, okay? Then I'm gonna divide both sides by negative 52. So I get y equals, you type that all in your calculator. Notice you're gonna get the same thing. So what's my answer?
Infinite.
Infinite solutions. I'm not gonna do part 2 just because of time. Alright, number 9. Under what circumstances does the system of equations ax plus y equaling b and then y equals lx plus m have no solution? So think about what no solution means. What's the biggest thing when you have no solution?
All the same.
Not all the
They're not.
same. Slopes have to be the same. That's the biggest point. Okay, slopes have to be the same and you have to have different intercepts. Okay? So, in other words, if our slopes have to be the same, first I need to get y by itself here. So y is going to equal negative ax plus b. So now I'm comparing this with this. So if our slopes have to be the same, that means negative a is going to have to equal L. Kind of a weird way of writing it, but that's what we got. They have to be the same. And then if our intercepts have to be different, what does that tell you about B and M?
It's hard for them to be different.
They have to be different. So B cannot equal M. These are your answers.
Heard one L.
I know, I heard it too. Alright, 2 more questions. Let's have you try these on your own. Let's see how you do. So 10, you're deciding 1, no or infinite. And then 11, you're doing the same thing. Alright, number 10. This first equation is good to go because y is by itself. This next one, I need to do some work. So I'm going to have 4y equaling negative x plus 1. Then I'm going to divide by 4. So y is going to equal negative 1/4 x plus 1/4. So you are comparing this and this. Notice slopes are different, intercepts are different. So when both are different, one solution. How'd you do?
Good.
Okay. Now this next one, notice your slopes are the same. Y-intercepts are different. So what is your answer? C, no solution. Very good. How you doing for a Monday? Can you handle it? It's kind of like you have a third chance, right? You have to pick one of the three. If you want to take a picture of the board to help you for your homework, I am fine with that, because I know that's a little bit easier to understand than the package, okay? I will be coming around with your homework assignment. Simon, did you collect absent work? So those of you watching the video, this is your homework. Get her done.